Hi, this is Sharon Holthouse, and I'm going to be talking about reproductive hormones for study question 613. We're going to be looking at the different hormones that are involved in the reproductive system, where they're released from in the body, what triggers that release, what their target organs are, and what effects these hormones have at their target organs. Specifically, we're going to look at how these hormones affect gamete development, or the production of sperm and egg. We'll look at how these hormones play a role in the physical changes that occur during puberty, and then we'll also look at how the levels of these hormones change as individuals age. I included this slide of the brain. This is a sagittal section because I wanted to point out the hypothalamus right here, and also the pituitary gland. So the pituitary gland hangs from the hypothalamus via this infundibulum, or this stalk of tissue, and these two structures are going to play a role in the release, and the production of reproductive hormones. To get ourselves oriented, on this slide, the hypothalamus is shown up here. This is the pituitary gland hanging from the hypothalamus. And the pituitary gland has two lobes, an anterior lobe and a posterior lobe. We're going to focus on the anterior lobe with this discussion. So that's shown in the darker color here. On this diagram, it shows 4 different hormones being released from the hypothalamus and targeting the anterior pituitary gland. These are all abbreviations for these hormones, and all of these hormones end with the letters RH, and that stands for releasing hormone. So all of these hormones will trigger, when they're released from the hypothalamus, they'll trigger the release of another hormone or hormones from the anterior pituitary gland. So the releasing hormone that we're concerned with today is gonadotropin releasing hormone. And that's shown by the light green arrow coming from the hypothalamus to the anterior pituitary gland. It will target the gland and trigger the release of 2 hormones that are made in the anterior pituitary gland. These are called gonadotropic hormones, and the first one is follicle stimulating hormone, or FSH. Second one is luteinizing hormone, or LH. So once these hormones are released from the anterior pituitary gland, they'll circulate throughout the bloodstream, throughout the body, but they'll find their target organs, or the cells that have receptors for these specific hormones, in the testes and the ovaries. Both of these hormones have effects in males and females. One kind of interesting fact or side note is that luteinizing hormone is often called interstitial cell stimulating hormone in males. And it's called that because this hormone binds to specific cells in the testes called interstitial cells. So it's not that this hormone is different at all in the male, but it does go by this alternate name. All right, so we're going to look at what effects FSH and LH have once they reach their target organs. Okay, so we'll look at follicle stimulating hormone first, FSH. So follicle stimulating hormone is going to target the ovaries. And specifically, it's going to support the development of follicles in the ovaries. These follicles, in turn, will then release the hormone estrogen. Okay, so if you look at an ovary, lining the outside border of an ovary are many, many of these follicles. And I included this diagram to show you a follicle, one follicle at various stages. But FSH will target many different follicles in an ovary. And this follicle includes an egg, and it's surrounded with supporting cells. Now, as this follicle develops due to the influence of FSH, it's going to start to get larger. You can see it getting bigger, and you can also see that there's more cells surrounding the egg, so it's starting to mature under the influence of FSH. It also then in turn releases estrogen. Okay, so you can see indicated by this arrow, now we see the ovary, specifically these follicles, releasing estrogens. Now the reason that estrogens is plural here is that there are different types of estrogens that are released, and we're not going to get into the specifics of those hormones, so we'll just group them together as estrogens. All right, on the male side of things, FSH targets the testes, the male gonads, and it is important in the development of sperm. So sperm production requires this follicle stimulating hormone. The second gonadotropic hormone released from the anterior pituitary gland is luteinizing hormone, or LH. It also targets the ovaries, and what happens is there's a sudden surge of LH which triggers ovulation. After ovulation, LH also supports the development or the formation of something called the corpus luteum. I'm going to go back a slide for a moment just so we can look at our follicle again here. So this diagram is showing a 28-day cycle, and a female cycle, it includes an ovarian cycle, so different changes with the ovaries, as well as, we'll learn later on, it also affects the menstrual cycle, or what's happening in the uterus. But what I want to show you here is that every month there's going to be one follicle that kind of becomes the queen or king follicle, and it gets quite large, and what happens about midway through the cycle is there's going to be a surge or a spike in luteinizing hormone, and that triggers the release of the egg from the ovary surface, and that event's known as ovulation. Once that egg is released, this follicle then is transformed into what's called a corpus luteum. This means yellow body. Luteinizing hormone is necessary to help support this transformation or this development of the corpus luteum. The corpus luteum is important because it in turn releases progesterone, another important sex hormone released from the ovaries. So if we go back a slide here, we see estrogens coming from the ovary, and we also see luteinizing hormone causing the release of progesterone as well via the corpus luteum. On the male side, luteinizing hormone, or otherwise known as interstitial cell stimulating hormone, will be important in testosterone production. And testosterone is necessary for sperm production. It also plays a role in targeting other organs in the male. We'll talk about that in a little bit. All right, so now we're going to look at the female sex hormones, the estrogens and progesterone. So we're looking at the ovaries. We've talked about how the follicles are involved in different stages when they release estrogens and progesterone. And the release of these hormones is cyclic, meaning that they are not at static levels or stable levels throughout a female cycle. There's going to be times during that cycle when the levels are high and times when the levels are low. So I included this diagram of the developing follicle followed by the corpus luteum. Again, here's the event of ovulation. And down here we're seeing the hormone levels in the bloodstream. So you can see that as the follicle develops, we're getting more follicle cells around the outside of the egg. It's going to be releasing more estrogen. Okay. Then we have that event of ovulation, right? And that's triggered by a rise in luteinizing hormone, which also triggers or supports the development of the corpus luteum. And remember, that produces progesterone. So now we've got high levels of progesterone in the second half, or most of the second half of that female cycle. Okay, so these are cyclic. Their levels in the blood will change throughout a female cycle. Now, if a pregnancy happens to occur, then the placenta will soon take over the role of producing estrogens and progesterone. The placenta is a structure that's derived from embryonic tissues as well as the uterus, and it's really is the lifeline for the fetus. So it's attached to the uterine wall, and the fetus is attached to the placenta via the umbilical cord. So the fetus's blood and the mother's blood don't mix, but they get very close to each other so that the mother can provide nutrients and oxygen to the fetus, and the fetus can get rid of waste such as carbon dioxide and return that to the mother. So the placenta has many important roles, but another important role is that it takes over this job of producing estrogens and progesterone. And these two hormones we'll look at later on in more detail, but they're very important for sustaining and supporting a pregnancy. All right, so now estrogen and progesterone are going to be in the bloodstream. Again, different levels depending on when you would take that blood sample from a woman. The target organs that are involved, one important one is the uterine lining. The endometrium specifically. This is the most inner lining of the uterus. And as estrogen levels rise, it's going to cause the uterine lining to thicken. It's going to become more filled with blood vessels, so there's greater vasculature. It becomes more glandular during that time. So if you look here at the estrogen level in beige here, as it's climbing or going up, you can also see this indicates the uterine lining, and you can see that it's also thickening and it's starting to have more blood vessels in there. Okay, so then after this event of ovulation, we have progesterone, and that, now that it's at high levels, it's going to target the uterine lining and cause these glands to start secretions. So its role at this point is to help support that thickened uterine lining, very lush, rich area in case that egg that was released at ovulation, in case it's fertilized, it could implant into this very nutrient-rich, supportive uterine lining. All right, estrogens and progesterone also play a role in the development of secondary sex characteristics. primarily estrogens. They play a larger role in this. And secondary sex characteristics are not always directly part of the reproductive system, but they definitely distinguish males from females. So one secondary sex characteristic that's stimulated by estrogens is breast development. So during puberty, a female will start to have larger breasts. Her genitalia will become larger. And also we start to see changes in body shape. So, you know, a girl's body shape compared to a woman's body shape is very different. And you'll see that the hips start to widen. And also the deposition of fat, where fat's being deposited, will start to change. And there'll be more fat deposited in the thighs, the hips, and in the breast tissue as well. And the uterus also develops due to these estrogens. All right, so feedback, what kind of feedback is there on the anterior pituitary? Remember that the anterior pituitary releases what we call the gonadotropic hormones, and those hormones include FSH and LH. So once there's higher estrogen levels in the blood, this starts to inhibit the release of FSH. Okay, so it's kind of a negative feedback system there. On the other hand, this rise in estrogen triggers that sudden surge or release of LH, luteinizing hormone, right before ovulation, or the surge that triggers ovulation. So the estrogen in the blood has an effect on that anterior pituitary gland. Okay, let's look at the male side here of things. So the production of testosterone happens in the testes, and specifically in the interstitial cells. And we talked about how LH targets those interstitial cells. This is a great image here that shows us part of the testes. What we're looking at here are structures called the seminiferous tubules. They're very, very long lengths of these tubules in the testes. And it's inside of these tubules where the sperm are produced and where they mature. So you can see as the sperm develop, they actually move towards the center of the tubule, and you can start to see in the middle of these tubules the flagella in these more mature sperm. So these are the seminiferous tubules, and these kind of burnt orange cells here are the interstitial cells. Okay. So testosterone is produced by these interstitial cells. And these cells, or excuse me, then testosterone targets the seminiferous tubules in the testes, and this causes sperm to form and to be produced and to develop. So this hormone, testosterone, as far as its target in the tubules, doesn't have too far to go. But it is necessary for sperm production. Testosterone is also circulating throughout the bloodstream of the body and contributes to the development of secondary sex characteristics. So again, enlargement of the genitalia. The larynx, or the voice box, gets bigger during puberty, and there's an accompanying lowering of the voice with that larynx enlargement. There's also going to be greater bone mass in males, And again, we talked about in females how it's that transition between a girl's body and a woman's body, same thing. It's a transition between a boy's body and a man's body. So the shoulders become broader, and also more skeletal mass develops under the influence of testosterone. Men also tend to have lower body fat than women, and that is contributed to testosterone as well. All right, so we're going to look at puberty, and this is a time when males and females start to develop those secondary sex characteristics. And it starts with the increase in production of GnRH, or gonadotropin releasing hormone. Okay, and if we've kind of followed this cascade of events, right? We had GnRH, and then that caused the release of these gonadotropic hormones. Those target the gonads, and then the testes and the ovaries are releasing these sex hormones, testosterone, the estrogens, and progesterone. But the very first hormone that you would see going on the rise when puberty starts is gonadotropin releasing hormone. Now, the onset of puberty is variable from individual to individual, and also girls tend to start puberty earlier than boys. So it's about age 8 to 10 for girls and 10 to 12 for boys as far as when it starts. Girls tend to go through puberty a little bit quicker. Boys, it tends to last a little bit longer. And again, definitely some individual variation there. So once puberty starts, it will last about 5 to 6 years, but again, it generally is drawn out a bit more for males. All right, so once there's significant sex hormone production, the testosterone and estrogens and progesterone, and again, estrogens have more of an influence with the development of secondary sex characteristics in girls. But there will be an increase in hormone production, significant increase. And towards the end of puberty is when this will trigger the menstruation, the start of the shedding of the uterine lining in girls. Also during puberty, gamete production begins. So the production of sperm and egg will begin during puberty. Again, it's not going to be the first thing that starts. It's going to be after there's enough sex hormones circulating throughout the body. I don't know if you can hear my cat meowing. I think he wants dinner. But anyhow, let's look at how these hormones change with as people age. So with women, the sex hormones will drop quite significantly, and this can be abrupt in some individuals, or it can be more gradual. It does happen around the age of 50. Again, a lot of individual variation there. And the levels of progesterone and estrogen will fall significantly. And gamete production will cease after menopause. Now, menopause is the stopping, I guess, of menstruation. Okay, so in menopause, all the ovarian follicles that we talked about are used up, and so the gamete production ceases, and at that point, because eggs aren't being released any longer, then really there's no need to go through the menstrual cycle, so that will stop as well. You will hear about how postmenopausal women are at greater risk for pathologies like osteoporosis and atherosclerosis. So what's been found is that the sex hormones actually contribute to maintaining bone density in women. So once these drop, women are more susceptible to osteoporosis or low bone density. And atherosclerosis is a clogging or a buildup of plaques in the arteries, and it's also correlated that there's a protective function of the sex hormones against atherosclerosis. Boy, my cat's really hungry. Okay. Changes with aging in men. So testosterone also declines as males age. But gamete production does continue, and it can continue throughout life. However, by 65 years of age, the sperm count is about 1/3 of what it was in a male's 20s. And by age 80, it's about 1/5 of what it was in the male's 20s. So the gamete production continues, however, the viability, the quality, and the number of these sperm will decrease. I should also mention with the decline of testosterone is that tends to be more gradual than the decline that you see in women. All right, so I think I better go feed my cat here. I don't know if you can hear it, but he's now meowing quite a bit. But let me know if you have any questions about these reproductive hormones, and you'll be hearing about these hormones in the next few lectures, so this is a good foundation for you for what's to come. All right, thank you.